Oh, by the way, if you have flash drives, pill containers make excellent cases for flash drives. Put down. All right, I'm going to go through this real quick because I've already done this. It's a good review because now you know you should focus on this for test 2. All right, first thing I talked about is Lewis structures. And Lewis structures is how you show the valence electrons for an element. And how you do that, you put one dot on each side and then you double up. And if we look at oxygen, one of my favorites, what I have down there. How do you do that? Well, let's do sodium. How do you do Lewis structure for sodium? Sodium has one valence electron. Put a dot on one side, doesn't matter which. Oxygen, 6 valence electrons. One on each side, and then double up. Organic chemists like to double up top and bottom. You can do it on any side. And that's how you do Lewis structures. Now, I talked about chemical bonds, and you should know there are 2 types, ionic and covalent. And if you remember on the board, I had hint, know this, and this you should know. What is an ionic bond? An ionic bond is a transfer of one or more electrons from one atom or group of atoms to another atom or group of atoms. Don't forget, everything you see up here is on the blackboard for you to download at your convenience if you wish. And so that's an ionic bond. Transfer one or more electrons from one atom or group of atoms to another atom or group of atoms. Covalent bond is, I gotta do my favorite thing, sharing, like holding hands, sharing pairs of electrons. So ionic, transfer one or more electrons from one atom or group of atoms to another atom or group of atoms. Covalent is always sharing pairs of electrons, pair being 2. Octet rule, I will never ask on a test, but you should know atoms either obtain, give up, or share electrons, so they have 8 valence electrons. And we talked about valence electrons already, the octet rule, 8 valence electrons. How do you form ions? Ions are when you either gain or lose electrons. And we talked about how you look for the nearest noble gas. And if we go if I were to ask you what ion does sodium form, You look at that and say, sodium, alkali metal, how many electrons and protons? 11 electrons, 11 protons. What's the nearest noble gas numerically based on atomic number? Either have neon 10, argon 18, which is closer, time's up, hopefully you'll pick neon 10, one away. So it wants to have 10 electrons, but you don't lose protons. If you find a way of doing it easily, let me know. We'll be rich beyond my wildest dreams, which get pretty wild when it comes to money. Anyways, now you do the math. 10 times each electron minus 1, 11 each proton plus 1. Add this up, you get a plus 1. How do we show the cation? When there's only one, you show plus. If there's more than one charge, like a plus 2, you show the sign and the number. Now, if I were to ask you oxygen, what ion does oxygen form? Oxygen, 8 electrons, 8 protons. And what's the nearest noble gas? Neon, which has 10 electrons, but you still have the 8 protons. I'm going to share them. Why don't you figure out, based on what I have on the board, what ion does oxygen form? Done, don't forget to look up and smile. Oh, it works. Glad you smile for smirking. All right, looks like everybody's done. How do you do the math? Take the board and say each electron is a minus 1, each proton is plus 1. Add this together, minus 2. You can show it like this or like this. I like this way, the first way, but that's the older way. More people nowadays are doing it the second way. Both are correct. Important thing you should know, I mean really should know, so all molecules have a net zero charge, and therefore, if I ask the following, what's the molecular formula for a molecule which calcium plus 2 cation, chloride minus 1 anion? How do you know what to do? This is a plus 2. This is a minus 1. This is a dirty board that I'm going to clean up. Better. This should add up to 0. If it doesn't, you can't change the charge, but you can change how many. And therefore, to get this to 0, I'll put a 2 there. How do I write that? 1 calcium, 2 chlorine. We talked about polyatomic ions. And how would you do the same thing? Again, this is a +2. This is a -1. It has to add up to 0. How do you change that? You put a 2 there. Now with a polyatomic ion, how do you show that? Well, I have 1 calcium, but how do I show 2 nitrate? I put it in a bracket. To the right subscript, I put a 2 there. And since I should share, why don't you try this one? What would be the chemical formula for molecule with magnesium +2 and bicarbonate -1? All right, let's do this. And the question is, how do you do this? How do you determine what the formula is? This is a +2. This is a -1. It should add up to 0. Does it? That's a funky looking 2. Hold on. Where the heck is it? I feel better now. And well, I can't change the charge, but I can change how many. And how do you show that? Formula, 1 magnesium, Gesundheit, and polyatomic ions, you put in a bracket, I need 2 of them, and that's how you do it. Next, I talked about a covalent bond. Covalent bonds are where you result from sharing pairs of electrons, 1 or more, between 2 atoms. How do you do a Lewis structure? I showed you. And if I were to do this Lewis structure for ammonia, 1 nitrogen, you look at valence electrons. By the way, the important ones I know by heart by now, I better. Nitrogen has 5 valence electrons, hydrogen 1 valence. The only way you're going to make this work is with the nitrogen in the center. Put my 5 valence electrons. Then each hydrogen has 1 electron. And now it's time to use the magic chemistry hands. And each atom should have an octet of 8. The exception is hydrogen. The octet rule for hydrogen is 2. So if I go like that, 2, 2. And that's shared or alone, 2. And so far, so good. Now nitrogen should have 8. If I go like this, 2, 4, 6, 8, I'm done. And we'll be doing some more of these in lab this week for practice. Electrons involved in a bond are called bonded electrons. Pairs of bonded electrons, notice 2, 2, 2 pair. Pairs of electrons that are not involved in a bond are called non-bonding electrons. You can have bonds with polyatomic ions, which have both covalent and ionic. If I do sodium hydroxide again. As soon as you see an alkali metal or an alkaline earth metal, that means the first two columns excluding hydrogen of the periodic table. These always form cations. I know of no exception where they're in a covalent bond. So, sodium, what ion does it form? We just did that, so I don't have to do it again. Plus, and then oxygen, 6 valence electrons, hydrogen, 1. And notice there's a bond here, but oxygen doesn't have its 8 electrons. Why not? Because I forgot to write where did this electron that left go. It went right here. It now has its 8, but it has an extra electron. So hydroxide is a -1 charge. And this has an ionic bond and covalent bond in the same molecule. I talked about there are different types of covalent bonds. Oh no, I feel it coming on. It's class participation time. Class, the first type of covalent bond is, everyone. Ah, that was pathetic. Let's all get together, fire up. Average was 86 on the test. Most of you did good. First type.
Single.
Thank you. Second type.
Double.
Last type.
Triple.
I'm not going to push it anymore, you people are burnt out. Anyways, single bond has 1 pair of electrons. Double bond has 2 pair. Triple bond has 3 pair. How do we show something like that? Let's look at something that's all of us are finding important. You're all inhaling, yep, you all are. Oxygen, draw the Lewis structure for oxygen. Gas, you have each oxygen has 6 valence electrons. How do we continue on? This oxygen says, oh, I have 2 unpaired electrons, you have 2 unpaired, let's share. And they do. The non-bonding electrons stay there. And what kind of bond is between oxygen, this is the hard part, how many pairs of electrons? Hold on. Let me increase the font of the dots. And there are 2 pair. What kind of bond between oxygens and oxygen gas? 2 pair, a double bond. We did practice, we'll do some more. Vesper was, I'll talk a little about that this week in lab, but that's off. And the other thing I talked about, hydrogen bonding, how are we doing time-wise? Not all covalent bonds are created equally. Some atoms are stronger than the others, so when they shear, they don't shear equally. A prime example, smaller case delta means slight charge. If we look at water, oxygen is stronger. We call that electronegative, which won't be on the test. That means it keeps the electrons closer to it than hydrogen, not equal sharing. There's a slight negative charge on the oxygen, slight positive charge. Opposites attract. You should know this. Call that a hydrogen bond. How many of you felt the review was good? Smile. And with that, I'm going to let you out a whole 18 seconds early. For those who have lab, don't forget to wear proper clothes. You don't need your goggles tomorrow, but usually the lab you're handling, and those who do this, I will see you in lab tomorrow.